So that was Led Zeppelin's Stairway to Heaven, which is not the most played song on the radio, but it's the most requested song on the radio. And many consider it to be the greatest rock song of all time. There was even a radio station that was started, and all they did is play Stairway to Heaven. Just put it on a repeating cycle. And while I think it's an amazing song, the radio station didn't last very long. Okay, a bunch of announcements. Most of them we've seen before. Homework 3, of course, is a Pirate Speak translator. It is due this Friday at 10 a.m. Some people have mentioned that our English grammar, we got the pirate grammar down, but our English grammar was not quite up to snuff. And in particular, we should have said I desire to instead of I desire. Let me actually show an example of that. And the question was, can one change the homework a bit? So, come on. Okay. So if you actually go down, you'll notice that right around here, everything else is I would like to, I wish I knew how to, my mother told me to, my companion would like to, and I desire doesn't have a to. So you're more than welcome to add I desire to. Just make sure that just I desire works. So you can add an I desire to in addition to just the I desire. Just make sure that everything that's there works. I mean, you're welcome to add, more pirate speak if you want. At some point we say, feel free to add other pirate words. As long as you keep everything that's there, you can certainly add anything you would like. No? So, Lab 3 grades will return this weekend. Homework 1 grades, they're all done. I just have to post-process them and send them out. So this week, of course, we have Homework 3 and Lab 5. Next week is both a midterm and a lab quiz. And the midterm itself will be this Wednesday, will be a week from this Wednesday here in class. Obviously, you have about 15 minutes to do it. Previous exams are already posted on the website. So they have them, I think we have the last 2 semesters worth of exams, and there's links to find out more information. Keep in mind that previous semesters, the class was 1 hour and 15 minutes. So the length of the exams is obviously not representative of what you're going to have this semester. We're going to scale it down to about 2/3 of the length of the exams that you will see online. The test itself, the exam here in lecture, is closed textbook, closed notes, closed everything. The quiz that's during lab session, so basically the day after the exam, you show up to your lab session and you take a quiz, which I'll get to in a second. That is open textbook, meaning if you have the course textbook, you may use it. You can't use any notes, any online resources that aren't explicitly allowed in the quiz, et cetera, et cetera. The way a lab quiz works is you show up, and at the appointed time when the TA says go, you start the lab quiz. You have, 1 hour and 15 minutes to do it. It is, the only questions you can ask are things like, my computer won't boot. I mean, if you have a compilation error, you can't ask a TA to come fix it, unlike the labs. And in fact, the TAs we're all going to be grading the exams during that time. In the past, I'm not going to guarantee this, but in the past, we have been able to take 400 or 500 exams on Wednesday and have them return the following day in labs. We are going to try to do that. Obviously it may not work out if, we have yet another blizzard or whatnot. But usually at the end of labs, we're able to have that lab section's tests returned to them. We'll see if we're able to hold up to that this semester. Either way, the exams will be, the grades will be posted probably that Friday up on the website. And yes, I have gotten complaints 36 hours after the exam one semester. I got complaints that people were saying that the exam was returned too late. And I kind of chuckled because there aren't many classes that will return exams that quickly. Other questions, comments, concerns? Okay, so we were moving through the Chapter 3 material. I forgot my stylus today, as you can tell. So we've been moving through the Chapter 3 material, And we're going to get to ifs. We may actually get to them today, if not for sure on Wednesday. We're going to start talking about if statements. That's actually what Thursday's lab is all about. So we should be able to get through the material here in lecture in enough time for the lab. Although the homework on ifs is not going to be until after the first exam, the if statements is valid, is fair game for the test itself. So we've talked about Boolean expressions. Booleans, of course, have two values, true and false. You can AND them, you can OR them, and you can NOT them. And what you can do is combine them into more complicated things. And we're going to see exactly why in a lecture or two. But what I wanted to do is go over an example of how to translate English into Boolean expressions. And the problem is that Boolean expressions are very precise. It is either true or false, and you can exactly figure out which is which. English, not so much. It's a bit on the vague side. And as we're going to see, sometimes we have problems translating English into Boolean expressions. So the first thing I want to do is I want to talk about the NOR operator, N-O-R. NOR stands for not or. It's not actually in Java, but it makes the example I want to go over well, it makes it possible. So P NOR Q is equal to not parentheses P or Q. All it does is it takes the or and it negates it. Turns out there's also a NAND, which is just not AND. But all NOR is not of the OR. And for various reasons, the NOR operator is represented by a down arrow. I don't care if you remember what the operator is. Just know what NOR is. And if we actually look at this, here we have our truth table. This is P or Q. If one, the other, or both are true, then the OR is true. Only when both is false is the OR false. And the NOR is the exact opposite. When this is false, it's true. And when this is true, it's false. So it's just the negation of the OR. So if we wanted to do NOR in Java, we'd do it this way. A bang, parentheses, P or Q. Not P, parentheses, P or Q. So why do I go over the NOR operator? We've seen this before. I have neither given nor received help on this exam. So let's try translating that into Boolean logic. As we're going to see, we run into some problems. I am going to rephrase that slightly. I have not given nor received. The question is how do I actually translate the neither? It could be that the neither just applies to the given, or it could mean it applies to the given nor received. I'm actually going to go over both examples. But for now, bear with me. I'm going to say that the translation, an equivalent either English translation, I have not given nor received help on this exam. So P is I have given help on this exam. Q is I have received help on this exam. And now my translation is not given nor received. Right? I have not given nor received. And as we're going to see, there's perhaps a different translation. That's the next slide. So remember that the not is done first. So the not, it's a unary operator. It only applies to the P. And here we have P, Q, not P, and not P nor Q. Now, if this statement is true, that means that you have fulfilled the honor code. And you'll notice something, that there's only one line, right, so that tells if we have fulfilled the honor code. You'll notice that there's only one line that fulfills the honor code. In particular, you have given and have not received help on the exam, which is probably not what we're looking for here. What we'd like is just the bottom line to be true and the rest be false. So what this is saying is that according to this translation of the honor code into Boolean logic, the only way that you can follow the honor code is that if you have given help but have not received help. This is the line we'd really like to be true. If you have not given and you have not received help on this exam, then it should be true. So I think we can all agree that this translation doesn't work quite so well. So let's try a slightly different translation. I have neither given nor received help on this exam. I'm going to say I have not given nor received. Now notice there that, again, P and Q is the same. Notice now that I'm putting parentheses around my nor. It's not parentheses P nor Q. On the previous slide, it's not P nor Q. Here, the not applies to the entire thing. So a nor is a not of an or. So if we not it again, we're just going to get the original or. So under this translation, it's essentially P or Q. Now you'll notice we're in even more trouble, because here is us following the honor code, and if we have given and have received help, we followed it. Only given, we followed it. Only received, we followed it. And if we didn't do either, then we're in trouble. Right. So all of those were following the honor code, and that one we're not. So what we really mean by this is I have not given and I have not received help on this exam. This is another way to phrase it that translates cleanly from English to Boolean logic. Or I have not, parentheses, given or received help on this exam. Either one of these would work. This, by the way, these are De Morgan's, if you remember De Morgan's law, if you not an or, you not each individual one, and you change the or to an and. So this is a way to rephrase it. And if you actually look at this, you'll notice that suddenly we have the right honor code, in that if you have not given and you have not received, then you fulfilled the honor code, and if you've done one, the other, or both, you have not fulfilled the honor code. And the problem there is partly that not has a higher priority in terms of it's done first, it has a higher precedence, and partly it's a problem of translating English into Boolean logic. In particular, neither is kind of vague. It is clear what it is meant in English, but not in Boolean logic. So my point to this is to try to show you that it's not always easy to translate Boolean logic, translate from English to Boolean logic. There are many times it's vague, right? It is clear to any human what the honor code means. It is not clear to you can't just directly translate that into a Boolean expression. You can't cheat and say, I told you so. You can't go into another class, cheat, and say, well, Professor Bluefield said that. I'm allowed to do it. This is just an example to show you why English to Boolean translation has some problems. Right. I want to make sure this disclaimer is there so I don't get in trouble. Okay. So let's talk a bit about floating point number comparison. We talked about integer number comparison, right? You can use the double equal sign, x double equals y. That's comparing the two values. It's checking to see if x and y have the same value. Let's assume they're ints. They have the same value, and it's going to give you either a true or a false, depending on if they're the same value or not. X single equals y is saying I'm going to assign to x the value in y. I'm going to copy this value into there. So let's say we had this code. So public static void main string args, we take double y and we add 10 0.1s, which you or I would know should be 1.0, but you'll notice that it doesn't actually work that way. And this is so much easier if I had a stylus. Learn how to use a computer. There we go. So this is the code. It obviously goes right past the end of the screen. But if I was actually to run this code, oh, no, that's compiling it. Here we go. That's the run button. You'll notice that it doesn't actually print out 1.0. Although it's hard to see it in the back, there's a lot of digits there, and there's more digits than should be in a 1.0. So here what we're trying to do is we're adding 0.1 a total of 10 times, but we're not getting 1.0. Instead, we are getting 0.999999999. So the problem there is that the way computers represent floating point numbers is not really precise. if I was to represent the integer value 3, it is exactly 3. If I represent the double value 1.0, it's pretty much 1.0, but not exact. So when I'm sitting here trying to add 10 0.1s, and imagine that I remembered a semicolon there, it is not exactly 1.0, even though it should be. So if I was to write this code, again with my semicolon, C and B are actually equal to each other. They should not be, but they are. B is not equal to A. So this 10 0.1s added together is not equal to A. Again, it should be, but they are not. These two things are false expressions. These two are not equal, so that's going to be false. And these things are equal, so that's going to be false. The problem here, the reason I'm bringing this up is you should be aware that you can't really compare floating point numbers that easily with the double equals. Generally, the double equals will be used for integers, characters, not really Booleans, but integers or characters are things that you are going to use the double equals for. Using floating point numbers, in particular doubles, as you can see, it doesn't always work quite so well. So one way to, obviously the way to fix this is you never compare floating point numbers. But what if you want to find out if two numbers are pretty close? Well, this, of course, applies to doubles and floats. We only care about doubles in this course. So what instead we're going to do is we're going to try to find out if two numbers are close in value. If 0.999999 and 1.0 if they're pretty near each other, then we're good. So what we're going to define, and just for this particular code segment, is a constant epsilon. Epsilon is 10 to the negative 6, 7, something like that. It's a kind of small value. And it's basically saying if any two floating point numbers, the difference between any two floating point numbers is less than that value, then we'll say that they're equal. And this would actually allow the previous slide to work. So now instead of checking to see if they're equal, we're going to check if the difference between them is less than that. And this is how we'd actually do it. So we take our two floating point numbers. We'll assume they're A and B. So A minus B, that could be negative. It could be positive. Math.abs gets the absolute value, or it makes sure it's positive. So this is getting the difference between them as a positive value. And it's checking to see if that's less than epsilon. So if you get, 2.5 and 1.2, the difference between them is going to be 1.3. 1.3 is not less than this value, so that's going to be false. If you get it from the previous slide, 0.9999999 and 1.0, you take the positive difference between them that will be less than epsilon, so we'll say they're close enough. So this is one way to go about comparing floating point numbers, because you can't always compare them directly. And a lot of times what will happen is people will try to compare them directly, and they'll run into no end of problems because their code won't work. So this is a known problem in computers. This happens in most programming languages, if not all programming languages. It's just something to keep in mind. So this is from the sandcastle competition, somewhere near the ocean. They got a bridge out of that. I'm sorry? Yeah, I saw that too. I was lucky if I got the bucket shape to look right when I flipped it upside down. I'm wondering if I was ever going to get in trouble for showing that, but I hope not. Okay. So we have a couple more things that we need to go over before we actually get to if statements. So we've talked about how to compare things. You can compare things and put them in order. 6 is less than 7. 7 is greater than 5. And by using these comparison operators, less than, greater than, less than or equal to, greater than or equal to, we can ultimately put many things in order. And of course, we've seen these as mathematical operators. Keep in mind that it's a less than and then an equal sign following it, or greater than an equal sign following it. So if you take those 4 operators and the equality operators, the double equals and the not equals that we've seen before, those are called relational operators, meaning they can tell how 2 things relate. This is less than that, this is greater than or equal to that, maybe this is equal to that. So using these, you can all figure out how 2 values relate to each other. In particular, most of the time we're going to be doing this with ints, integers or characters. If we do it with booleans, it turns out that false is less than true. True is greater than false, they're not equal to each other, etc. So, given those values, you can sit there and find out each of these is going to return a boolean value. Right? J is not less than K because they're equal to each other. So that would be false. That's true. That's true, etc., etc. With characters, it becomes slightly more complicated. In particular, all characters have some sort of numerical representation. The character 0 is 48, capital A is 65, little a is 96. I don't want you to remember the numbers that each character corresponds to. I just want you to know that there is a correspondence. In particular, if character 1 is number 49, then character 2 is 50, character 3 is 51, and it goes up sequentially like that. If 65 is A, 66 is B, and 65 plus 26 is going to be Z. So we could say A is less than B, because when Java looks at it, it looks at A as 65, B as 66, so it's going to think A is less than B, if you are comparing characters that way. In particular, big A is going to be less than little a, because big A is 65, little a is 97, 65 is less than 97. So, and then we can sit there and start comparing our characters. We have a character C, D, and E, and we can start comparing them as well. Right? C is less than D, C is not less than E, etc., etc. So, we have seen many different types of operators: addition, subtraction, multiplication, and it turns out that there is a specific order that Java evaluates these in. And this is from most important to least important. The first thing it does is parentheses, just like math. First you do what's in the innermost parentheses, and you keep on going. Unary operators, that's like a not sign or a negative sign. Not a minus, meaning 3 minus 2, but like a negative sign like negative 3. Multiplicative operators, times, divide, and modulus. Additive operators is plus and minus. Relational ordering is the 4 less than or greater than ones. Less than, greater than, less than or equal to, greater than or equal to. Relational equality is equals or not equals. We have and, the 2 ampersands, the 2 vertical bars for or, and of course the assignment is a single equals. And what happens is Java will always, always, always execute them in that order. And generally that's the same order that mathematicians will use for them as well. So I wanted to spend a bit of time talking about expressions versus statements. We've seen statements before. A statement is a command in Java that tells Java to do something. Create a new vector. Print out this line of code. Ask the user for input. Maybe it's a standard in .next. A statement generally, and as far as we've seen always, ends in a semicolon. And pretty much everything we've seen so far is statements. And these are all some statements. Each of them tell Java to do something. Well, an expression is some sort of mathematical equation that gives you a value. So, for example, 5. That gives a value, the integer value 5. Circle.getRadius. From the circle object, call the getRadius method. I don't know, maybe it returns 2.0. A variable, that's an expression. 3 plus 2, x over 7. These are all expressions. Notice that they don't have a semicolon, and all they are used is to get a value. These, we're not really worried about values. With an expression, it's something that will give us a value. 3 double equals 4. That's going to give us the Boolean value false, because 3 and 4 are not equal. 6 is less than 7. That's also going to give us a Boolean value false, because 6 is not less than 7. Those are expressions. In particular, if you just do the plus plus I, what that's going to do is that's going to take whatever value is in I and increment it by 1, and you're going to use the incremented value. Right? So that'll actually give us a value that we can use. You could write system.out.println plus plus I, semicolon. Plus plus I with a semicolon after it is actually a statement. It's telling Java, I'm going to add 1 to I, and if it gives us a value, we don't really care about it. The difference is both of them are incrementing I. The top one, or the first one, is using that particular value. And that's generally what we're going to see, we're going to use expressions for, is anytime we want to generate a value. Int x equals 3 plus 2. Well, the 3 plus 2 is an expression, evaluates to 5. And then the int x equals 3.2 semicolon, that's the entire statement. That's telling Java, create an integer variable x, give it value 5. The 3 plus 2 is just the expression that gives us the value we're going to store in x. Apparently my spacing is off. So these are new ones that came out in 2005. Inspiration. Genius is 1% inspiration and 99% perspiration, which is why engineers sometimes smell really bad. I'm not saying I believe in that. I'm just presenting them all. Wishes. When you wish upon a falling star, your dreams can come true. Unless it's really a meteorite hurtling towards the earth, which will destroy all life. Then you're pretty much hosed no matter what you wish for, unless it's death by meteor. This is one of the ones that was voted very highly and is or was hanging up in my office. Beauty. If you're attractive enough on the outside, people will forgive you for being irritating to the core. Pressure. It can turn a lump of coal into a flawless diamond, or an average person into a perfect basket case. Okay, so we've talked all about Boolean statements, and I think I've pretty much beat them into the ground. Now I want to show you how to do ifs. What we've talked about so far is everything we've seen is linear. It starts at the beginning of the main method, executes every command once and once only until it hits the end of the main method. That was true with homework 1, that was true with the vector homework, that was true with the pirate speak homework. We're now going to see ifs. And ifs will allow us to do one or more statements either 0 times or 1 time. As we're going to see, in the next chapter, there's ways to do a statement like 5 or 10 times. So there's two main categories or 4 different ways to go about doing this in Java. The first category is if statements, and that has 3 of those ways. If else, and if else if. And then there's a switch statement. And we're going to see all of those in this slide set. And again, it allows us to choose for a given section of code, a series of statements, do I execute it 1 time or 0 times? That's the syntax for an if statement. If, parentheses, some sort of expression, then action. And here we have flowcharts. I think flowcharts are kind of dippy. Although that's more the way I think a lot of people use them. But I think when showing these basic statements, excuse me, puberty and all, when showing these basic statements, flowcharts are sometimes useful to briefly explain what's going on. Anything in a diamond means it's going to evaluate some value, And if it's true, we're going to follow this arrow. If it's false, we're going to follow that arrow. If the expression here or there is true, it's going to execute action. If it's false, it does not execute action. If this is true, then do that. That's essentially what this is saying. A couple things to note. This expression must be a Boolean. It cannot be anything else. And if you try making it something else, an integer expression, a double expression, Java will complain and not compile your code. So it must be a Boolean expression, and it must be surrounded by parentheses. Even if it's just a Boolean variable x, you still have to put it in parentheses. Oops. Right. If expression's true, then execute action. As it turns out, action can be either a single statement or a group of statements separated by curly braces. And I'm going to show examples of that on the next couple slides. So here we have, if value is less than 0, value equals negative value. At the end of this section of code, value will always be non-negative. It could be 0, right? And 0 is not positive. So we can't say it's going to be positive. But it definitely will not be negative. Because if it is negative to begin with, then this will be true. And it will make value equal its additive inverse, meaning it will make it positive. So a couple things to note here. Value less than 0, that's a Boolean. Or it's a Boolean expression. We have our parentheses. And you notice we have our curly brackets. What that's saying is that if the expression is true, I'm going to execute everything from the starting curly bracket to the ending curly bracket. Here we have our flowchart. I don't know if flowcharts actually add anything, but I'll show them anyway. If value is less than 0, then we're going to negate it. If value is not less than 0, then we just keep right on going. Right. That's everything I talked about. I'm going to skip over this purple stuff because I just rambled on about it. So let's say we wanted to take in two values from the keyboard, and we wanted to sort them so we knew which one was less than the other, or which one was greater than the other. So here we have the code that will read in two values into value 1 and value 2. Right? Reads in two integer values. So we want to make sure that value 1 is the lesser of the two values. It could be that they're equal, and that's fine. But if value 2 is the lesser of two values, if value 2 initially, let me start that over. We want to make sure value 1 is the lesser of the two values. So if it's the case that value 2 is the lesser, if value 2 is less than value 1, we're going to swap the values. And then we're going to print them out in sorted order. Value 1 is the lesser of the two, and value 2 is the greater. Well, it could be equal, but we're ignoring that. So all that if statement does is it swaps the two values. What this does is it backs up value 1. This overwrites value 1 with value 2, and it puts into value 2 the backed up value of value 1. So that's effectively swapping those two values. So you enter 11 and 28. Value 1 is 11. Value 2 is 28. 28 is not going to be less than 11. It will not execute the code. It's going to print out 11 and 28. If you enter 11 and 4, value 1 is 11. Value 2 is 4. 4 is less than 11. It swaps them, and it prints out 4 and 11. And here we have a flowchart for part of that code. In particular, if value 1 is less than value 2, it's going to swap them. Otherwise, it's going to print out the stuff at the end. And of course, the input is off the top of the screen. Right, blah, 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 blah. How many people feel they understand if so far? All right. So, given an if statement, Java will execute the next block of code if the if is true. And a block of code is either a single statement, such as this. Notice I don't have any curly brackets. if A is equal to B, that's of course double equals for comparison. I'm going to print out, hey, they're equal. Notice there's no curly brackets. So Java will then print out that line if and only if A and B are equal. Or I could put curly brackets and have more than one statement. In particular, if there are no curly brackets, only one statement is executed. And if there are curly brackets, it's going to execute all the statements between the two curly brackets. So a block is either, in this context, is either a single statement or a multiple statements enclosed by curly braces. You'll notice we have nice indentation too, so that this is over, 3 spaces, so that, or however many spaces, but it's over a certain amount, so we know that that's what's actually executed on the if. So now if we look at this code, m is 5, n is 10, and it says if m is less than n, which it is. Now, the thing here is that there are no curly braces. So the only thing Java is going to execute on the if is plus plus m. But the indentation makes it look like both of these should be executed if the if is true. But because there are no curly braces, it's only going to do the plus plus m. If there was a curly brace here and then a closed curly brace here, then it would do both on whenever the if was true. And this ends up being a bit of a problem. If your indentation is off and you mix it up slightly, it's easy to make the mistake of what code is actually executed on the if, meaning when the if is true. Oops. So for that reason, we're going to suggest that you always, always, always use curly braces. It's only 2 more characters. It's not going to give your fingers carpal tunnel syndrome any more than they already have. But it will save you a lot of headache if you always use curly braces, even if it's only one statement, because you won't run into these problems. Okay, questions on ifs. So obviously a week from tomorrow is an exam. And it turns out that exams in cs101 have been rather lethal to grandparents. In particular, grandmothers. It always happens that grandmothers of students will often die shortly before the exam. And, I certainly heard about this. Whoops. No, go back. And it turns out that I wasn't the only one. So there's this one person. Oh, give me a break. Way to screw up my joke. All right, this is worth it. We're going to reconnect here. And in the meantime, let me do the backup. Oh, wait. Wait, is it working? Okay. There we go. So this has been called the dead grandmother exam syndrome and the potential downfall of American society. And basically what this study did is showed that the closer you get to an exam, the more likely it was that a grandparent would pass away, necessitating that student to miss the exam. Here is the really interesting thing from that. It turns out, there's a couple graphs, blah, blah, blah. It turns out that the chance of a grandparent dying is proportional, inversely proportional to your grade in the class. And what this is showing is that if the current grade is an F, you have a much higher chance of a grandparent dying than if your current grade is an A. And what these 2 lines are is this is the chance that an average grandparent would die, based on the fact that you're all, just under 20 years old and the generation gap, age gap between you and your parents and your grandparents. This is the chance that a grandparent would suddenly pass away prior to a midterm, and this is the chance that a grandparent would suddenly pass away prior to a final. And you notice it was a dramatic increase. So this worried a lot of people because people, people were dying as a result. So the study actually focused on what we could do about it. All right, another table. Another statistically valid thing. And they give a couple ways to solve this. One of which, of course, is to stop giving exams because, I mean, the theory is that these grandparents are stressing themselves to death about their grandchildren in the class, especially when the grandchildren aren't doing very well. So we could stop giving exams, but then it's no fun. Only allow orphans to enroll at universities. Therefore, you wouldn't have any grandparents to worry themselves to death. Or have students lie to their families. Meaning, don't tell your grandparents that you're not doing well in their class and that an exam's coming up. And this way, grandparents would not pass away.
Don't worry, I think you can safely say that most of us are looking out for our grandparents already.
Well, you know, and it's funny because, I mean, people have asked, why do I do this? And this is partly in response to that. People ask, well, why do I go over this? I've had grandparents pass away too. I'm not making fun of grandparent death. And people have asked, well, why do I go over this? I'm saving lives. Because before I went over this, I had a half dozen grandparents that died. Since I've gone over this for this semester and the last 5 semesters, 2 grandparents have died. And the first semester, like half a dozen died that one semester. So instead of an average of 6 per semester, I'm down to like a third per semester. So I'm actually saving lives by going over this. Because people are getting better excuses. I mean, grandparents are dying much less now that I go over this. Right. That being said, I always have to go over this about a week before exam time. Then I get some other reasons why people have to miss the exam. So, all right, we've seen the if statement. And you think I kid, I really had a lot of grandparent deaths or reported deaths until I started going over this. I think I've had like 1 or 2 since. We've seen the if. If something is true, I'm going to go ahead and execute this code. But what if that something is false? Well, it turns out that we then have an if-else statement. If expression, action 1, else action 2. What that's saying is that if the expression is true, I'm going to execute action 1. Else, or otherwise, meaning if the expression is false, I'm going to execute action 2. Here's our flowchart. A nice, pretty red. If expression is true, I do action 1, then keep going to the blue dot. If expression is false, I do action 2 and keep going to the blue dot. So the only difference between an if and an if-else is the fact that the else clause will be executed when the expression is false. Else doesn't have to be there. Sometimes we'll see else, sometimes we won't. So let's say we wanted to find the maximum of 2 values. We're going to read in 2 given values, and we want to find out what the maximum is. Kind of like putting them in sorted order, but with a slight difference. Int maximum. Notice that I am creating a new variable maximum that's going to hold the higher of the 2 values. And if it so happens that value 2 is greater, meaning if value 2 is less than, value 1 is less than value 2, maximum is the greater of the 2 values, or value 2. Else, maximum equals value 1. So now once this code is finished, the maximum variable will have the higher of the 2 values. A couple things to note. I have my curly braces, which are not needed because I only have one statement, but again, we're recommending you use those. And my else also has curly braces. You'll notice that there is a parentheses with a Boolean condition after the if, but not after the else. This right here is a comment. So Java ignores this entire part. That's there so that a human reading it knows when the else is executed. If value 1 is less than value 2 here, then the else is done when value 1 is greater than or equal to value 2. So this whole thing here is solely a comment. As far as Java is concerned, it's going to ignore it, and the only thing it sees is the else curly bracket. And then I can print out the maximum of those 2 values is maximum. The question is, we do not initialize maximum when we declare it? And will Java give us an error there? Well, Java actually looks at this code, and it realizes that one way or the other, maximum has to be given a value. Because either this if will be executed and maximum is given a value, or this else is executed and maximum is given a value. Either way, one way or the other, maximum must be given a value because it's going to do this or that, only one, obviously not both. So when Java looks at it, it realizes that even though we don't initialize maximum here, at some point in this code, maximum is given a value prior to when you try to print it out. So Java won't complain.
Does the maximum have to be on the line after the else?
Here? Yeah. The question is, does the maximum equals value 1 have to be on the line after the else? It doesn't have to be as far as Java is concerned, but in terms of our nice, easy to understand and easy to read programs, generally, yes, it should be. You could have all this on one line, right? Take out the comments, have one great big long line. But in terms of easy to read, we do want indentation as well. So notice this code. Here it's pretty much the same thing, except I've taken out the else. And Java is going to complain that maximum might not be initialized. Because what will happen is that if value 1 is less than value 2, meaning this condition is true, then we're giving maximum a value. And Java's happy it's initialized. But if value 1 is not less than value 2, maybe they're equal, this code is never executed, and nowhere is maximum ever given a value, and Java's going to start complaining. So the particular error message it gives is something like variable maximum might not have been initialized. And what it means is that it's possible to get to this part here when the integer variable maximum has not been given a value, right? Because if these two are equal, that's false, that's not executed, and we get here without ever giving maximum a value. Here we have our flowchart. Wow. You can tell I'm not a huge fan of flowcharts. Right. So if we look at this code, you'll notice that it's a bit harder to read. Where does the if start? What's done in the if? As it turns out, this is code from before, and all of this is done in that if. But you'll notice that it's not indented, so it ends up becoming very difficult to read. This is why we like using white space. Going back a slide or two. Let's go back one more. The fact that this is indented tells us that that's executed when this if is true. The fact that this is indented tells us that that's executed when the else is run. But when I don't do any indentation, it becomes confusing as to what actually is executed when. So for that's why we actually like to do indentation. It makes the code easier for you to write and debug and to figure out what's going on in your code. It makes it easier for the graders to actually grade the code, which means if you don't do proper indentation, we love to take points off for that.